All right, so now we're going to get into one of my favorite parts about trig. There's a lot of favorite parts, but this is where we start to see how algebra and trig relate, how they're similar, how they're different, how we can use algebra within trigonometry as we can with geometry as well. But a thing I want to emphasize is don't let algebra be the reason that you struggle with trigonometry, right? And this is actually true with a lot of things. We can say don't let algebra be the reason you can't do calculus. This is usually where people get bogged down, is they make algebra mistakes, which makes it seem that trig is hard, but it's not. So here's an example of a mistake. That's not something we can do. All right, so I want you to try. I'm going to have you do a lot of these are going to be quick. Try to simplify the expression up here and simplify the expression up here. Pause the video, do that, unpause when you're ready to discuss. So hopefully we know that w plus w is 2w. Therefore, cotangent of x plus cotangent of x is going to be 2 cotangent of x. Just think about when you first learned addition when you were in, I don't know what grade. But I have a thing and I'm adding it to another of the same thing. So this doesn't become 2 cotangent of 2x, or it doesn't become cotangent of 2x. Did anybody put cotangent of 2x? You don't have to raise your hand. That's all right. Okay, but again, we're just adding 2 of the same thing, so we have 2 of those things. Okay, try this one. Again, pause the video, unpause when you are ready to discuss. All right, so hopefully everybody disagreed. This is not correct for our simplification. And here's why, because this is how we would actually simplify it. So now let's back up a second. The word simplify in mathematics is really ambiguous. There's what one person argues is simpler than another. It can change. It can also change on what we're trying to do with the thing we have, expression in this case. But if we are going to try to do anything here, the only thing we can do is we can split up the fraction since there is a single denominator. So this becomes xy over y minus w over y. And now I can reduce the y's in the term on the left. So I get x minus w over y. We just saw this. So now that we know this is x minus w over y, I want you to try and simplify sine of x, tangent of x, minus 1 over tangent of x. Pause the video. Unpause when you're ready to check. All right, so here we should end up with sine of x minus cotangent of x. And you might ask yourself, wait a minute. So how do we get that? Well, first I did the same thing that we did up here, and I split up the fraction. So when I split up the fraction, now keep in mind, we talked about this when we first talked about trig, that this is sine of x. So x is part of the sine function. It's not sine times x times tangent times x minus 1, right? It's sine of x, then times tangent of x. You know, if you wanted to, you could, if I put parentheses here and parentheses here, it's the same thing. And then I could even add a parenthesis around the x so that I know that that's what the function, that's the input to the function. But that's what it means. So I split up the function, I split up the expression, the fraction. Now tangent of x in the numerator, tangent of x in the denominator, I can reduce that. So I get sine of x minus 1 over tangent of x. And maybe you're like, oh, that's good, except for wait, I swear there was something about 1 over tangent of x. Right, it is the reciprocal of cotangent of x. So therefore 1 over cotangent of x is cotangent of x. Sorry, did I say that right? 1 over tangent of x is cotangent of x. I'm talking a little quick. Maybe I misspoke. But this is the correct conversion. Next one. All right. I want you to try and simplify x squared over x, xy over x, and then I also want you to try to simplify cosine squared x over cosine of x, and secant of w, cosine of w over secant of w. Pause the video. Unpause when you're ready to check. All right, so hopefully we understand that x squared over x reduces to x, xy over x reduces to y, because this is multiplication. Now, on the bottom here, we have cosine squared of x over cosine of x. First, well, I guess. So this simplifies the cosine of x. But I want to emphasize this notation because we haven't really seen this yet. So when we write cosine squared of x, that is the same thing as the entire quantity cosine of x squared. We just usually don't write this form. We usually write it this way because it's a little bit cleaner to write. But we want to understand it means the same thing. It does not mean the same thing as cosine of x squared, right? So what we're trying to emphasize is the difference between squaring the x versus squaring the entire quantity of cosine of x. It should make sense that those are two different things. Now, if I write this here in the blue, this is ambiguous because am I saying that the squared is on the x or am I saying the squared is on the whole thing? It's hard to tell. In this case, honestly, if it was written like this, I would personally assume that the square is on the x. So don't write things like this. But cosine squared of x is the same thing as the quantity cosine of x squared. We want to understand that. Also, I want to point out that whether we put the parentheses around the input or not does not matter. A lot of times you'll see me write them just because it makes my writing a little bit cleaner, but it is not necessary. A lot of times when we see trig functions typed, it is not, the parentheses aren't going to be there. It doesn't really matter either way. It's more if you're just trying to make something clear on what is an input to the function versus what is not an input to the function. All right, back to this. So if I have cosine squared of x, that means this is the same as cosine of x times cosine of x. So I can reduce that with one of the cosine of x's in the denominator, and I'm left with just cosine of x. Here I have secant of w times cosine of w over secant of w. Similar to up here, I can reduce those, and I'm left with just cosine of w. Next, I want you to simplify x plus y over x and sine of x plus 1 over sine of x. Pause the video. Unpause when you're ready to check. Okay, so for the first one, we can split up the fraction again. We've seen that technique, and we get x over x plus y over x. X over x is 1, so it's 1 plus y over x. Another thing I want to point out, this is a important notation thing just for math in general. But notice that I'm not putting equal signs here. I'm either drawing an arrow or I'm just working vertically. We don't want to just start creating a bunch of equal chains or equal signs and then chaining them all together because that is mathematically incorrect. This is not an equation, so I'm not trying to say that this is equal to this. Then it would seem like I'm trying to solve something. So I either draw an arrow or I work vertically. So here I chose to work vertically. This is actually a good way to do it. It kind of keeps your work in order. So again, I split up the fraction, sine of x over sine of x plus 1 over sine of x. Sine of x over sine of x is 1, because anytime we divide two things that are exactly the same, that's 1. 1 over sine of x is cosine of x. That's cosecant of x, sorry. So this is my answer, 1 plus cosecant of x. A couple of things to think about when we're simplifying these trig functions. You know, we're not going to get into all of the rules and strategies of it yet, but just things to think about. If anytime I can get rid of a fraction, I want to do that. That's going to be simpler. So that's why, although sine is a, maybe we would say more common trig function, 1 over sine of x, changing that to cosecant of x is always going to be considered simpler, so to say. Again, there was my air quotes that you couldn't see. Okay, so I want you to try to do both of these. Factor 4 minus x squared, factor 4 minus tangent squared of x. Pause the video, unpause when you're ready to discuss. All right, so hopefully we recognize 4 minus x squared is the difference of squares, so that becomes 2 minus x times 2 plus x. If you have the order of these switched, that is okay. Remember, it can be 2 plus x times 2 minus x as well. Does not matter. So that still worked with trig functions, right? It's a perfect square minus something else that is a perfect square. In this case, that perfect square is tangent of x, quantity squared. We already talked about that notation a couple of slides ago, so we understand that's what this means. And so this factors into 2 minus tangent of x times 2 plus tangent of x. FOIL. Just side note, I hate this term FOIL. I feel like it makes it sound like something magical has happened. So we're actually distributing, but some of you are familiar with FOIL, so you understand what that means. So distribute y minus 2 times y plus 3 and distribute sine of y minus 2 times sine of y plus 3. Pause the video. Unpause when you're ready to discuss. So here I showed a little bit of more work with the algebraic expression. So y minus y is y squared, y times 3 is 3y, y times negative 2 is minus 2y, and negative 2 times 3 is minus 6. Combine like terms in the middle, 3y minus 2y is just y. So we get y squared plus y minus 6. The same exact thing will happen with the trig function. So sine of y times sine of y is sine squared of y. Sine of y times 3 is going to be 3 sine of y. And so actually I will show that just to emphasize. This would have become sine squared of y plus 3 sine of y minus 2 sine of y minus 6. Just to make sure we understand, that's how the algebra was mixing with the trig. So when I multiply sine of y times sine of y, that doesn't become sine squared y squared. We are not squaring the y's, we are squaring the function sine of y, the expression sine of y. All right, let's try another. Here we're going to expand. So you have x plus y squared, sine of x plus cosine of x, quantity squared. Pause the video, unpause when you're ready to check. All right, so here we know x plus y quantity squared is x plus y times x plus y, so I can distribute again, and I should end up with x squared plus 2xy plus y squared when I simplify. Therefore, I can do the same thing with sine and cosine. So sine of x plus cosine of x quantity squared is sine of x plus cosine of x times sine of x plus cosine of x. So when I distribute, I end up with sine squared of x, because sine of x times sine of x is sine squared of x. Sine of x times cosine of x is just sine of x times cosine of x. And then I have cosine of x times sine of x. I wrote it as sine of x times cosine of x. It does not matter. It's the same thing because 2 times 3 is the same as 3 times 2. And then cosine of x times cosine of x is cosine squared of x. Now we can combine like terms. I have two things here, sine of x cosine of x times plus sine of x cosine of x. Those are the same thing. So if I add them together, it's 2 sine of x cosine of x. So this would be my answer. Now, we haven't learned this stuff yet, but I do want to point out this actually simplifies further. So we're going to see some of this in a little bit, and then some of this you won't see until you get to an actual trig class. But we're going to learn in a minute that there's an identity, sine squared of x plus cosine squared of x equals 1. We're going to learn why that is in a little bit, but for right now, just understand it's true. So again, the dashed purple line is how I expected you to write your answer here. What I'm showing you now is just more for your knowledge, and maybe some of you have seen these things before. So I could write my answer as 1 plus 2 sine of x cosine of x. Great. That's awesome. But I can go further again. 2 sine of x cosine of x is what we call a double angle identity. Again, I don't expect you to know or memorize this now. This is something you'll learn about when you get to an actual trig class. But that becomes sine of 2x. I'm not going to prove that to you right now. You're just going to have to take my word for it. So another correct way we could write the answer would be 1 plus sine of 2x. Okay, let's do another one. Factor x squared plus 2x plus 1, and then factor cosine squared of x plus 2 cosine of x plus 1. Pause the video, unpause when you're ready to check. Okay, so this, we think about what multiplies to 1 and adds to 2, that's 1 and 1, right? So this becomes x plus 1 times x plus 1, or x plus 1 quantity squared. Either of these would be acceptable. Side note, this is what we call a perfect square trinomial. So the same thing is true with trig functions. Whenever we have the, like in this case, cosine of x, I just want to think of that as my variable, right? Because that's all one thing. So I'm not separating that in any way. So I have thing squared plus 2 times that same thing, and then plus 1. So that factors the same way that this did. So cosine of x plus 1 times cosine of x plus 1, or cosine of x plus 1 quantity squared.